A Timeline of the Development of Concrete by Jamie Klein, John Flynn, and Ridge Baker. Naturally occurring concrete has been found in Israel that dates back to at least 12 million BC. It was caused by a reaction between limestone and oil shale. Archaeologists have discovered evidence from 5600 BC of the early use of concrete in Europe. Along the banks of the Danube River in Yugoslavia, the concrete was used to make the floors of huts. In 3000 BC, China used concrete to hold materials together for bamboo for their boats and as mortar in the Great Wall of China. In 600 BC, the Greeks discovered a natural pozzolan that could be added to concrete to give it hydraulic properties. This allowed it to harden underwater. One of the earliest uses for this new type of concrete was to build water storage tanks. By 80 AD, the Romans were building many projects from concrete. Two of these included the aqueducts and the Colosseum. The aqueducts were built by Roman army engineers to bring fresh water to Rome and other major cities. The Colosseum was an outdoor amphitheater built to host gladiator fights and other special events. It was built from concrete and stone together, and one of the big secrets of the Colosseum was that the outdoor passageways used vaulted ceilings, which added a lot of strength to the building without adding additional weight. In 128 AD, the Romans built the Pantheon. It was one of their greatest engineering marvels, and the span of its dome was not surpassed for hundreds of years. Its dome was made in tapering steps that ranged from 20 feet thick at the base to 7.5 feet thick at the top. After 400 AD and the fall of the Roman Empire, many of the innovations the Romans had made in concrete were lost. Around 700 AD, the Saxons built the first concrete mixer. It was in the form of a shallow bowl cast into bedrock. A beam with paddles attached to it rotated about a central post and was powered by humans or animals. In 1756, John Smeaton rediscovered hydraulic cement through repeated testing in fresh and salt water. He discovered that cement would harden underwater if it was produced from limestone that had large amounts of clay. He produced the first high-quality cement since the fall of the Roman Empire. In 1824, a bricklayer and mason from Leeds, England named Joseph Aspin filed a patent for what he called Portland cement. The name came from its resemblance to stone from the Isle of Portland. In 1825, the building of the Erie Canal created the first large demand for cement in the United States. The cement that was used was made from hydraulic lime. In 1828, the first engineering use of Portland cement was credited to Isambard Brunel. He used the cement to fill a breach in the Thames Tunnel. In 1848, reinforcement was used in concrete for the first time by John Louis Lambert. He constructed several small rowboats out of concrete, using iron bars and wire mesh as reinforcement. In the 1850s, the first concrete roads were built in Austria. The idea spread to England by the 1865 and then to the rest of the world. In 1854, the first reinforced concrete building was created by William Wilkinson. He built a small two-story concrete servants' cottage that had the floor and roof reinforced with iron bars and wire rope.
In 1871, David O. Saylor established the first Portland cement plant in the United States in Copley, Pennsylvania. Although popular in Europe, concrete was not produced in the United States until 1871. Saylor experimented with selecting and mixing different kinds of rock from his quarries to produce Portland cement. In 1871, William Ward built the first landmark building using reinforced concrete in Port Chester, New York. The architect was Robert Mook. The reason why he used reinforced concrete was because his wife was terribly afraid of fire. Ward handled all technical and construction issues himself, and to this day the house still stands. In 1889, Joseph Mahalik designed the first reinforced concrete arch bridge. The bridge, consisting of two spans of 5 miles each, was built in the village of Salt, Hungary. What made reinforced concrete work so well for this bridge was the joint utilization of two materials, iron and concrete. George Bartholomew placed the first concrete street in the United States in Bellefontaine, Ohio. It still exists to this day. The street was an 8-foot strip. Studies show this pavement had a breaking strength of 8,000 psi, which is actually stronger than concrete used today. A section of this concrete won first prize at the Chicago World's Fair of 1893 for engineering technology. In 1902, Thomas Edison was a pioneer in furthering development of the rotary kiln. Edison's additions to concrete technology are not well known to the public, even though he had a great impact on how concrete was developed. He developed new cement processing technologies, including a giant rotary kiln in the old Yankee Stadium, which eventually allowed the Edison Company to increase production and realize cost savings. In 1904, the Ingalls Building was the first concrete skyscraper. It was constructed in Cincinnati, Ohio in 1904 and made use of the Ransom system of reinforcement. It was actually not only the first concrete skyscraper in America, it was the first concrete skyscraper in the whole world. Reflecting its importance as the first high-rise of its type, the Ingalls Building was designated a National Historic Civil Engineering Landmark in 1974. It was added to the National Register of Historic Places in 1975. In 1908, Thomas Edison patents a system of cast iron molds for a monolithic concrete house that forms walls, floors, stairways, roof, bath and laundry tubs, and conduits for electric and water service in one single casting operation. The plan was patented on December 22, 1908, and during the following months, Edison designed a series of complex molds which would serve as forms for his concrete houses. In 1910, a Norwegian civil engineer named Foner thought of using concrete to build ships. It wasn't until 1917, when wartime steel shortages required the use of cement for construction, that Foner's idea was used. In 1918, a concrete ship, the Atlantis, was commissioned. N.K. Foner of Norway launched the first ocean-going concrete ship, an 84-foot longboat named the Namsfjord. Seeing that this was a success, several smaller vessels were created. In 1911, with the invention of shotcrete, came the ability to place concrete in vertical or horizontal surfaces without formula. This process has paved the way for easier placement procedures and for an alternative repair method. Shotcrete is, in effect, a version of a cast-in-place concrete wall. Rather than placing concrete into forms, however, a fresh mix is sprayed onto wall panels that have been erected in the shape of the building. In 1913, the first patent for a concrete pump was filed. This made concrete transportation easy and allowed on-site mixing. The pump basically replaces the wheelbarrow in pumping. It brings the concrete to the place where it has to go. The speed at which concrete is pumped is a lot faster also. A wheelbarrow load of concrete is pumped in seconds with a pump. So really, it is much more effective than a wheelbarrow ever was. In 1914, the Panama Canal is opened after decades of construction. It features 3 pairs of concrete locks with floors as thick as 20 feet and walls as thick as 60 feet at the bottom. The total concrete for the canal in cubic yards was 5 million. The weight of 1 cubic yard of concrete was 1.5 tons.
In 1917, the first standards for Portland cement came about. These standards were set out and published in 1916 by the U.S. Bureau of Standards and American Society for Testing Materials, but did not come into effect until January 1st in 1917. This is a big leap from back in 1898, where there was actually 91 different formulas for the Portland cement. By creating this standard, it ensured that all concrete mixtures would be the same. In 1930, air entraining agents were introduced. These were used to improve the concrete's resistance to the freezing and thawing by adding small amounts of air into the mixture. Other advantages: the air bubbles increased the cohesion of the fresh mix, which means less bleeding and segregation. It also helped with workability and which was increased because of the ball bearing effect of the bubbles. In 1936 was the first major dams that were built. It was the Hoover Dam was one of them. It was a horizontal arch design which ensured the great compression strength of the concrete is employed. And then the Grand Coulee Dam, which is said to have enough concrete to build a 4-foot, 4-inch deep sidewalk that's twice around the equator. In 1936, Frank Lloyd Wright built the Falling Water, which is recognized as one of his finest works. Wright was also the first one to exploit the cantilever. Cantilever is supported by the reinforced concrete. The floors for it were upside-down T-shaped beams, which integrated into a monolithic concrete slab, which formed the ceiling of the space below and provided resistance against compression. 1962 was the beginning of the use of reinforced concrete in modern skyscrapers. This was used in the Twin Towers at Marina City in Chicago, and they both stood 558 feet tall. Whenever they were finished, the two towers were both the tallest residential buildings and the tallest reinforced concrete structures in the world. In 1967, the first concrete sports dome was created. The Assembly Hall was constructed at University of Illinois in Champaign-Urbana. A 400-foot pre-stressed saucer, the roof was cast into 24 segments of 15 degrees each. Each segment of the roof is 52 feet wide at the rim and 6.5 feet wide at the center. The central ring beam, or very center of the dome, is a heavily reinforced 4-foot thick concrete slab which contains 170 cubic yards of lightweight concrete. The entire roof is 2,880 cubic yards of lightweight concrete that weighed only 105 pounds per cubic feet. In the 1970s, fiber reinforcement was introduced. Concrete reinforced with fibers is less expensive than hand-tied rebar, while still increasing the tensile strength many times. There are different types of fibers that can be used. Steel is the strongest commonly available fiber and can come in different lengths and shapes. Steel fibers can also be used on surfaces that can tolerate or avoid corrosion and rust stains. In some cases, steel fiber surface is faced with other materials. Another type of fiber is glass fiber, which is inexpensive and corrosion-proof, but not as ductile as steel. In 1976, the CN Tower was completed in Toronto, Canada. This became the world's tallest freestanding structure on land, which stands 1,815 feet tall and made with reinforced concrete. To build the main support pillar, a hydraulically raised slip form was built at the base. This was a fairly impressive engineering feat on its own, consisting of a large metal platform that raised itself on jacks about 620 feet per day as the concrete below set. Concrete was poured continuously by a team of 1,532 people. In 1983, Syndicrete was developed. It was created as an alternative to limited or non-renewable natural materials. It's a lightweight architectural concrete composite made primarily of cement, western coal fly ash, and a waste of polypropylene fiber from a carpet manufacturing plant. This is used in many applications such as kitchen countertops, sinks, tub surroundings, tile flooring, and furniture. In 1995, insulated concrete forms began being used in homes. These are styrofoam blocks that are built up and poured full of concrete to create a house that is relatively maintenance-free. Due to the high density of the concrete, with added layer of foam, these new homes have a great insulating system and less sound is transmitted through the concrete walls than through conventional stud walls. In 2009, the Three Gorges Dam was built. The dam was built of solid concrete and steel and is over 7,000 feet long and stands 607 feet tall. The base width is 377 feet and the top width is 131 feet. The project used over 300,000 cubic yards of concrete and 463,000 tons of steel, which is enough to build 63 Eiffel Towers.